if you go back to where Mbar started, she talked about 26% of projects is all that actually achieves the results. And I know that we're towards the end of this valuable session, and so what Michael and I really wanted to do instead of present towards you was actually have a conversation about what are some fundamental elements where we see 26% actually originating from. What are the routine mistakes that people are making when they're looking at IoT? And one of the things that we truly want to apply here is this is a business discussion, and it's a data and IoT technology discussion. And oftentimes you're going to find those are bifurcated conversations. And there's a great deal of confusion around the landscape of the value of data and the role that it plays in IoT. So we wanted to spend some time here at the end of the day and just really have a conversation. Myself from a business landscape, as somebody that leads transformations, leads the transformation of Cisco, and Michael, who is far more in depth around the artificial intelligence and the technical side of things. So with that, we're going to sit down and just carry on the conversation. We wanted wine, but they wouldn't let us do it. So.
Great. Thanks so much, Kevin. All right. Well, you know, what you just said, I think, is very interesting. It matches exactly some of the studies that we've done at Intel about how people are using their data and what they're doing in the analytics area. And, you know, somewhere less than 30% of businesses have actually deployed successful advanced analytics programs.
So very similar, 30%, 26%, you're seeing same
thing. And those people who haven't yet successfully deployed the programs, most of them actually have some kind of an effort underway, but they're not successful because the reasons they give are, one, they're still ramping up their staff and their understanding of the technology. But secondly is, and this is one thing I think people are really struggling with in many cases, is where to apply the artificial intelligence or advanced analytics technology. Where does it make sense in my business, and how do I know that?
You just said advanced analytics, artificial intelligence. I think that's the underpinning is most people are confused. What is BI? What is machine learning? What is artificial intelligence? There's a lot of different buzzwords rather than actually understanding the maturation curve associated with data.
Yeah.
So,
yeah, let's see if we can clarify some of that. So I think most people are familiar with business intelligence. You all have, you know, data lakes, and you all have your data stores out there, and you're doing intelligence on, you know, what is the state of my business today, what are the trends, all of that sort of thing. But if we want to go to the next level and say, where is my business going tomorrow? How can I help predict what's going to happen in my business, predict what's going to happen with my customers so I can take the appropriate actions? Then we're moving into this area of advanced analytics, or now it's often called just machine learning. And so let's clarify some of the buzzwords and figure out what some of the key technologies are here, because it's important to understand this. So what people know most about is what we're calling classical machine learning on this slide. And classical machine learning is basically, you know, starting with machine learning. Machine learning means the machine is actually learning from the data. So, you know, your business intelligence, you know, you're taking the data that you have, you're visualizing it, but you're doing some pretty basic statistical computations. The machine's not getting more intelligent. With machine learning, as you feed it more data, it actually gets more intelligent. It gets better at classifying that data. It gets better at predicting probabilities of events happening, things like that. So on the classical side of machine learning, what happens there is a data scientist will come up and look at the data. Now, this is someone that's familiar with your business and familiar with the data that you're looking at, and they'll identify what's called features in the data. These features are the things that are going to be most indicative of the problem that you're trying to solve. Sometimes the features are automatically in the data, so in the healthcare industry, say you might look at features might be how many times someone was admitted to the hospital, what they were admitted for, what kind of medications they're taking. These might be key indicators of something you're trying to discover, like the probability that they're going to come down with congestive heart failure. So we identify the features, the data scientist does this, and then they apply, their selection of algorithms. And I'm not a data scientist, but people who are trained in this area, they know the difference between all these different algorithms and when to apply which one. And so they have the features, they feed the data in, they apply the algorithms, and then they do what's called training the system, which means they run the data over and over and over again, lots and lots of data, and they see how accurately the system can predict what they're trying to do. And that's how you develop a model, a machine learning model in the classical machine learning sense. And as I've described it, it's sort of obvious, but it applies primarily to data that's tabular, tabular kind of format, structured data for the most part.
Yeah. So you're seeing, I think a lot of us are familiar with this from a consumer perspective, and now what you're really defining is how do you move it into the enterprise landscape, and where will it be acceptable, where won't it be acceptable, and that's sort of some of the evolution is where it's not only confused, but also what is the applicability from a business landscape.
The applicability from a business landscape, and then also I think there's a category of use cases that classic machine learning just doesn't apply to. So okay. I talked about these data scientists being able to go in and identify features. What are the things that we're looking for in the data? So, but if your data is images, or your data is video, or your data is speech, if I wanted to tell the system to be able to look for Kevin Bandy, I'd have a hard time saying, well, you need to kind of look at the space between his eyebrows, you need to look at the size of his nose, how would you tell it to identify faces? So that's when we switch over to, the next the up and coming part of machine learning, which is deep learning.
And before you move there, if you were to take the enterprises that you've had exposure to and you begin to put them on a maturation curve associated with how they're progressing through there, where would you see them having moments of success, or actually just from a maturation landscape? Are they more in the classical machine learning in the early stages, or progressing up the curve?
I would say that most organizations are using some sort of a classical machine learning today. They may or may not be successful, but they have folks that are working on that today. And there are a lot of tools and technologies out there. And if you go and look at, say, typical analytic software like SAS or something like that, or you go to Google or Microsoft to their websites, all of them have a platform as a service that supports classical machine learning.
And in your personal experience, because I certainly have seen this, and I think Rowan talked about a great example today with the Tennessee Highway Patrol example, or the Department of Highway or Transportation. I continuously see people bifurcate IoT from a technology perspective and not from a data strategy, and they're fundamentally alienating the outcomes that they're after in the first place. And so when they're in their early stages of the machine learning, there isn't a definitive outcome they were chasing in the first place. They were just trying to deploy technology. Yeah,
that's a really critical point. It's if you don't know where you're going, you're not going to get there. And if you don't clearly know what problem you're trying to solve and what questions you're trying to answer, then your project is destined to fail.
Yeah, people tend to over-define rather than get DMAIC and where do I start and how do I begin to originate success, and so they artificially chase this maturation curve associated with their IoT projects, in my personal observation.
Yeah.
So walk us through deep learning.
So deep learning, is newer. So classical machine learning, people have been doing that for decades. Deep learning, its neural networks and so on have been around for a long time, but they haven't been very practical to use until very recently because of the advances in hardware and software technology that give us the performance we need to do it. So deep learning's different in many ways. Overall, you still have to train a model, but here, the data scientist doesn't identify the features. The deep learning system does it itself. So let's say you were trying to develop a deep learning system to identify images. One example we work with is we're working with a company to do preventive maintenance on oil rigs. And they have both drones that fly through the air, and they have undersea drones that go and take all these pictures of all the various parts of the oil rig, bolts and things like that. And then you need to go through and be able to identify which bolts are corroded and which bolts aren't corroded so you can go through and fix those. So in a system like that, you would just feed the deep learning system thousands of pictures of bolts, just bolts that where you've circled the ones that are corroded and you've left the ones that aren't corroded, and pretty soon it learns to pick out the bolts that are corroded. You can do it with identifying faces. You can do it with identifying, virtually any kind of object. And then you can expand that out into speech or other things like that. And just one more thing. So you do this training on the deep learning system, and then once it's trained, you can take that model and deploy it anywhere. So you can deploy it at the edge, in some kind of fog-based system or something like that, or you can deploy it at the back end. And today we see a lot of this. So when you talk into your phone, right, it understands you now. It didn't used to. 5 years ago, you get a lot of interesting responses, but now it understands you, and so that's running an inference engine in the back end that's learned to recognize speech.
Yeah. Skill sets different on each side.
They're somewhat different, yeah. The skill set of data science from classical machine learning does apply over to deep learning. There's still some additional things you need to learn, because even on deep learning systems, again, you iterate many, many times for the system to learn, and each time you have to tweak the models. You have to tweak what they call the weights of the data coming in. But someone that understands classical machine learning can pick up deep learning very quickly.
Yeah. I can tell you personally from a Cisco perspective, one of the things that we're actively trying to do, not only in building both of these into the network, and you heard Rowan talk about it, you heard Chuck talk about it, but the left-hand side, we really talk about actionable insights. How do we begin to get more of that and take, once you see it, it's presenting the opportunity. The right-hand side, we're moving into this notion of actionable accountability, which is redefining the capabilities by which we accelerate taking actions. Each have to be driven by a different outcome that we're pursuing. And the technology is an enabler, but what I find most often is our people have structured the data incorrectly before they ever started the project.
That happens very often, yeah, and that's part of the whole process. So, when you talk to like a data science person, and you talk to them about how they're doing artificial intelligence and where they spend their time, they'll tell you, and they pretty much agree across the board, that they spend 80% of their time just getting the data ready.
Yeah.
And then they spend the remaining 20 of it actually training the system and building the model and deploying the model. Yep. So that's a huge issue.
Yeah, I see people moving and confusing analytics with the steps associated with really what they're trying to automate. This is not just about automation, it's about automation around definitive outcomes. And what I personally believe that we're seeing is more and more the business lead is involved in this strategy, and the technology and the data scientists are fundamentally applying the science against a definitive business outcome.
Yeah, that's absolutely critical. So part of my job, part of what I do is I work with end users, customers like all of you, to implement.
Wait a minute, they're all your customers?
Yes,
That's
they're all our
impressive.
customers. How many of you? Is anyone out there not have Intel processors? Yes, they're all my customers.
Well done. Well done.
Yeah, so I work with folks, and a lot of times we'll get technologists calling us, which is fine. We want to know how the latest technology works in deep learning, and how do we have some tools they can use? And the answer is yes, we do. And can we help them get going? And the answer is yes, we can. But the next question we ask them is your line of business involved? Yeah. What problem, again, are you trying to solve? Do you know what problem you're trying to solve? Because technology for technology's sake is interesting the first time you do it. But as you get into it the second and third time, you really want to make sure, again, we say, what are the specific questions you want to answer with this artificial intelligence system? Because if you don't know, you won't get there.
And I think with that point, let's hit on a few examples of where, even though we talk about 26% or 30%, if you start with the right business outcome and the right data structure, and you begin to recognize you can be incremental in your successes and build on top of that, there's a lot of examples that are out there for you to really look at. If you look at, we're going to walk through 4 quick examples. But if you look at this one, costly, evasive activities here. The technology was not fundamentally approached in the development of this right here. It was actually, the focus was on the patient to begin with. And the business was presented back to the IT instead of IT presented to the business. And then it was a factor of what you just said. Let me structure the data around what I know around the patients and what I don't know around the patients. And when they began to approach it from a business problem first versus an actual, in the patient aspect, what they found was twice the level of improvement. IT had the capability, but they fundamentally were starting with what was the patient and mind implication, and tell me what I know and what I don't know. When I began to apply that, it really defined the algorithm.
Yeah, and in healthcare, that's so important because healthcare, I think, in particular, unlike maybe some of the other businesses, they're so entrenched, they're so ingrained in the way we deliver healthcare and the way doctors work that doctors are very sensitive to the implication that someone might be telling them how to treat their patient. And really what artificial intelligence systems do is help them decide what to do. It doesn't really tell them what to do, but it's been a very slow adoption in healthcare. Yeah. And so I think this example is a great one of where they got the treatment side of the house to agree first and then brought in the analytics.
And what the combination of the business and the IT landscape identified here is how do you double the productivity of the treatment, but it also defined where there was customization that was of value for the patient. And that was very beneficial for the doctors to understand where should standards apply, but then also to see the trends and the patterns associated with what becomes unique in the treatments, which advance their capabilities immensely. I think in this one, we talked about when do humans become robots, and I agree with Rowan, if I could just get printers to fundamentally move. In this particular example, it wasn't that they were trying to fundamentally remove the people, they were trying to double the workload, and what the humans did is they actually trained the robots through the mechanisms. It was the human behavior interacting with the robots that fundamentally taught them what were the mundane capabilities that were actually on. So it was the digitization effort where the people taught the robots the activities. It advanced people to move into a different direction, but it didn't eliminate work, it redefined the work that the people would do because the people actually trained the robots to replace them, and then they began to do something more meaningful.
Yeah, it kind of brings up that comparison of people talk about the industrial revolution, sort of replacing the repetitive, mundane physical tasks. And now artificial intelligence has the promise to replace the mundane, repetitive mental tasks.
Correct. And I think what you just said, the mundane mental, that's the sort of the first horizon that people need to recognize. Start there. Don't over-define the opportunity. Start with the solid foundation that you can truly begin to utilize data science and deep machine-based learning and artificial intelligence. Work your way through the curve. What he just outlined is the first mistake I see a lot of people do is they define grand versus where do they begin. Yeah,
and this next example is actually a good one to illustrate that. So, there in the healthcare world, there's lots of grand solutions for artificial intelligence that can cure everything, right? But really, none of those, or very few of those, are very successful. The ones that are successful are the ones that you just talked about, Kevin, where you take something that we already know how to do, that's already working someplace. And in this case, it was this idea of diabetic retinopathy detection. And the problem was not that we couldn't detect diabetic retinopathy early. We can. The problem was that, for many people who live in rural areas or poor areas that don't have regular access to healthcare, they don't go in for regular checkups because it requires special equipment. You got to go into the doctor, and they just don't go in. So the problem people were trying to solve here was how do we take the retinopathy scan to the patient out into these rural areas, because if people have this and they don't get treated, they'll go blind.
Yeah.
So it was, how do we apply, Internet of Things technology, so a portable camera of some kind that can take a picture of the eye, feed that into the smartphone, where a trained model, this inference engine, sits, and it can tell you, the relative risk of diabetic retinopathy. And this has been very, very successful. It's actually been re-implemented many places. I think Stanford started it, but it's been re-implemented in Oklahoma, Texas, in China for rural areas there. It's been a great success for.
So is that a good example of deep learning where once you actually prove the model, you can actually begin to share that across? So if you built it in one area of your business or across an industry, it's highly repeatable, those insights?
Well, the particular model can be redeployed. The inference engine, as they call it, the execution side of it. If you develop imaging models, you can reuse many aspects of it, but if you're going to use it for a new application, you do need to retrain it on data that's specific to that application. But it shortens the development cycle significantly if you start with something that's already, doing image recognition in particular, a particular type, or it's doing speech recognition or text or something like that.
Okay.
Yeah. So this is another kind of different example. So this is a company called Blue River Technologies. And what they did, again, was take what was a very manual, labor-intensive process that also required, sort of a repetitive intelligence, which is, taking care of crops. So, farmers, they go through and they, plant their crops, and then they have to go through, and because they overplant, because not everything comes up, so they have to thin the crops, typically space them out so every plant has enough room to grow, and then they have to fertilize them and weed them and so on. So and usually this is a person, a person going through the fields doing this. So Blue River Technology said, well, I can take this very manual process and let's automate it. But they wanted a machine, a robot, just like you see there. You tow behind the tractor and it does all those things that I just talked about. But in order to do that, it has to be able to find the plants. And it has to be able to tell, how far apart these plants are and what kind of plants they are. So we worked with them on image recognition of being able to identify the plants and to even more so identify where the stem of the plant connects to the earth. And that's what you see with the bottom part of the image there, is that those little yellow squares that was actually the training data. That was where we told it to look, to teach it. But what it's really hard to see in this picture here is there's a little red dot in the center of each one of those is where the deep learning algorithm actually identified the plant as being. So essentially it's saying it was very, very accurate in doing that.
And how long did it take to actually put this level of scenario in motion?
It doesn't take that long. Like you said, the longest part is getting the data together, right? So for deep learning, you need tens of thousands in some cases, millions of images to train the deep learning system. So it's coming up with those images, and you not only have to have the images, they have to be labeled. So you have to teach it. You have to take 10,000 pictures of corn from all kinds of different angles and go in and draw a little box of where you want it to learn to identify the corn. That is where it meets the earth.
Yep.
So that's called, labeling the data. And that's hard and takes time, but the interesting thing is wherever there's a need, right, there's some business that gets born. And so there are now businesses out there that's what they do, is you give them a bunch of images and they'll go in and label those images for you.
But I think the way you just summarized that is critical. It goes back to your very first piece to understand the difference between machine-based learning and deep learning. Is I think we really have to make sure that people understand the evolution of the curves associated with data and data strategy, because so many of the failures that you see across IoT were over-engineered against the wrong data sets, they're over-engineered against the wrong business outcomes, they're confusing one with the other, and you're setting yourself up for failure. And that's why if you look at the images versus machine-based learning, radically different algorithm by which you're going to actually pursue these.
Oh, radically different, yes, yeah. So you're right. You got to, before you pick the tools, you got to know what you're going to build.
Yeah. So if I was to look at how do you begin in advanced analytics, clearly we've talked a great deal about understanding the foundations associated with what are the different data elements between one versus the other. don't over-engineer to begin with. Actually start with some of the proper data foundation. But if I was to look from a business level perspective, again, you're the technical side of things, I'm the business side of things, and I think collectively across IoT in this artificial intelligence landscape, more and more you're seeing business and IT come together around defining definitive outcomes together. What would the technology enable? But the technology enabling something without definitive business strategy and business outcomes is not going to be an effective strategy. So you really have to marry these two things together. And so the one thing I would tell you right in the very center of my first column, and you said this earlier, you're talking to a great deal of line of business owners. And you're first focused on what is the outcome that you're meant to solve for from your seat. And when I first met Michael, I asked a very simple question, where do people fail? And he asked the question right back at me, and I said, incorrect outcomes. They very seldom understand what they were trying to solve in the first place. And you're over-engineered. So I think that's the point that I would like people to really take away is there true alignment across the line of business? Do I have a clear enough strategy that would define incremental success that I could learn from and begin to refine? And so from my seat, that's the first column, that's where I'm focused on.
Yeah, I think that is absolutely correct. The other takeaways are, make sure that you have the right folks, right? So data scientists are not just a dime a dozen. They're kind of hard to find. Another category of people that are hard to find as well are what they call these business transition specialists. It's kind of a newer area, but it is the people that understand the technology and understand the business and can marry the two together. It's not as easy as it sounds. And then, just to illustrate that a little bit further, give another great example. So if you're wondering, I have a lot of healthcare examples because I focus in the healthcare industry. But we worked with a hospital system who had all the right pieces. They had, executive management involved. They had the nurses and the doctors involved. And they had all the data science folks they needed to get their systems up and running. So they created some good predictive analytics systems. One of the ones they created was a system to predict sepsis. So sepsis usually comes on fairly quickly, and if you don't respond to it quickly, the person dies. So it's very, very serious and most times fatal. So their idea was, everybody said, well, let's get more runway. Let's see if we can predict who's going to come down with sepsis earlier. And they were able to do that. They were actually able to predict, in some cases, 20 hours in advance, where previously, just by looking at the patient, you had maybe an hour or 30 minutes. The interesting thing is the project initially failed. They rolled it out to the wings in the hospital. And what they found out was that the hospital's pathways had been geared up for a crash response, for an emergency response. So when they said somebody has sepsis, they rolled the emergency card out to treat this person. When they said this person's going to come down with sepsis in 20 hours, the hospital didn't know what to do. They didn't know how to treat that. So they had to kind of go back to the drawing board and say, let's create a clinical pathway for early analysis sepsis, so we know what we're going to do there. So just saying, you got to be flexible. You got to understand that even if you do everything right, you may end up having to go back and visit again because you discover you've changed your business. You've fundamentally changed something about your business, which is probably ultimately what you want to do.
And I think that's the point. And you heard it in every one of the examples. Every time that when we looked at what we could automate across the heart research, what we found were the anomalies of where we could re-educate the doctors to do something radically different. We found the things that were there that they could standardize that validated what they knew, but we also defined the things that could double productivity. But the nuances of how they could begin to customize treatment was an education and a learning opportunity. It wasn't what they asked in the first place. It wasn't what they were asking, what do I change? And what Michael just summarized is, at the core of conclusion, be prepared to change. Automation is not the end game. Automation with the advancement of your business outcome, changing your business model and constantly moving up the analytical curve and applying the automation through your IoT landscape. Challenging change is challenging the business model. And that's where I think one of the areas that this is why the line of business and the IT have to be in it collectively together, because it's inevitable that you're going to change.
Yep. And if you're not in it together, you're going to fail.
Yep. With that, we're out of time. So I hope that was helpful. I would actively encourage you to spend time with Michael. The man is a wealth of knowledge around artificial intelligence. I personally have enjoyed the time getting closer to you over the course of the last 30 days, getting ready for the IoT World Forum.
Great, and I've really enjoyed the opportunity. Thank you very much, Kevin.
Sure thing. Thank you, Michael. Thank you, Bob.